Hello there, algebra students. This is Mr. Kashi speaking. This video we're going to go over our first day of factoring quadratics. That is in Module 10, Section 6. And it's kind of the opposite of what we were doing before, earlier in the module of multiplying binomials. So I'll explain this today's video and next time's video as well. But really it deals a lot with factoring numbers and then just splitting the expression apart. So hopefully you can see we have n squared plus 7n plus 12. This is a quadratic trinomial expression, and we're going to factor it, is what they say. So we have to take a look at our last number of 12 and our middle number of 7. And this is called the diamond method. We're going to create kind of a diamond looking thing here. We have 12 and 7. And what we have to do is we have to find two numbers that multiply to 12 and add to 7. And if you take a look at your factor sheet with 12, hopefully you can see that 3 and 4 are those two numbers. So we have 3 and 4, because 3 times 4 gives us 12, 3 plus 4 gives us 7. And then what we can do is we can split this expression up into two different sets of parentheses. One is going to be n plus 3, and the other is n plus 4. So hopefully you remember from earlier in the module we did something called the box method. So if I'm just going to do this for this first example, I won't do this for all of them, but if we were to multiply these two together, we could put an n there and a 3 there, n there, a 4 there. We multiply here, we have n squared, we have 4n, 3n, and then 12 right there. And then we'd combine these to get our n squared plus 7n plus 12. So it's just going back and forth. And so just so we're clear, this how we started is what we call standard form, and then how we ended is called factored form. Okay, and so what we did earlier on in this chapter is we multiplied. So we started here and we went up this way, and that's called just multiplying. It should be an L, multiplying, and we use the box method shown below to do that. Now what we're doing is we're doing the opposite of that. We're starting here in standard form, going down to factored form, and we call that just factoring. So hopefully you kind of understands how we're just kind of doing the opposite of what we did earlier in the chapter. And this goes kind of quickly once you get a hang of it, but you are going to need to have some practice on it. So here's another example. We have p squared plus 9p plus 20. So we have 20 and we have 9. That last number is always the one that we have to multiply to get to. So we have to multiply to get to 20, and we need to add to get to 9. So we need two numbers that do that. And if you take a look at your factor sheet for 20, hopefully you'll see that 4 and 5 are those two numbers that do that. 4 times 5 gives us 20. 4 plus 5 gives us 9. So we'd be able to split this up into p plus 4 and p plus 5. And it's plus 4 and plus 5 because these are the two positive numbers that we are talking about. So this is a positive 4 and that's a positive 5. So that's why we have the p plus 4 and p plus 5. So both of these examples had addition signs in between those three terms. So now let's go into an example that doesn't have two addition signs. So the process is the same. We have x squared plus 2x minus 8. We're going to create our diamond, and we're going to put negative 8 up here. We're going to take this whole thing, and then 2 is going to go down here. We have to multiply to negative 8, and we need to add to 2. And so here, the factors of 8, 1 and 8, that's not going to add to 2 at all. But 2 and 4 has the potential of adding to 2. So we have to have 2 times 4 would give us a positive 8 and a negative 8. So one of these factors, the 2 or the 4, has to be negative. And as you can see, we're adding to a positive 2, that means our larger number has to be positive. So here, that would be something that you might want to write down as a note. This would be an example when the larger factor is positive. So I always think about which one is winning. So the larger factor is positive. And so then we would be able to write our answer in factored form, which would be x minus 2 and x plus 4. That would be your final answer in factored form. So the next thing, the next example that we're going to go through is very, very similar. We have y squared minus 6y plus 8, so I'm going to create my diamond again. It's going to be a positive 8 up there and a negative 6 down here. So we have to find two numbers that multiply to 8 but add to negative 6. Now, in this case, we're still going to use 2 and 4, but in this case, they both have to be negative, because a negative times a negative is going to equal a positive. So negative 2 times negative 4 gives us a positive 8, but negative 2 plus negative 4 gives us a negative 6. So this would be a case with both factors are negative. And then you just write your factored form here. We have y minus 2 and y minus 4. All right, those went kind of quick. I have one more example. In this case, I just wanted to kind of do this one for a couple of different reasons. One, if there isn't a number in front, remember there's always going to be a 1 there. So when we go to create our diamond, we have a negative 12. That whole thing comes, and then we have a negative 1. So we need to multiply to negative 12, and we need to add to negative 1. We need two numbers that do that. In this case, we have 3 and 4, which are 1 away from each other. But here, one of them has to be negative, and here the larger factor needs to be negative, because we have to add to a negative 1. So 3 times negative 4 gives us a negative 12. 3 plus negative 4 gives us a negative 1. That'd be another note. This would be a case where the larger factor is negative. And then you'd be able to write your factored form answer as x plus 3 and x minus 4. So hopefully these examples help you out with the different scenarios of when the larger factor is negative, when the larger factor is positive, when both factors are negative. I just wanted to try to give you multiple examples that had different looks to them.